Hi, my name is Nathan Thompson, and my project is the water current turbine. I got inspiration for my project from large turbines that use ocean currents to generate clean energy, so I thought it would be cool to scale it down and make one myself that is more portable using what I know. It was a big challenge to face, but I learned a lot and had lots of fun along the way. My first idea was to make my own wire coil and get magnets to rotate using the propeller to get the electricity flowing. This ended up not working, and I knew I had a lot to do, so I had to move on. I then modeled a design that would accommodate for a new motor I got that replaces the handmade wire coil. You can see a hole here on the side for the wires to come out of. That is where the charging cord would be plugged into. The main body is perfectly symmetrical all the way around other than the wire hole. Its small size makes it perfect for a shallow stream. The front has a slope inwards that helps direct water into it to ensure maximum flow. When the propeller rotates, it moves the motor shaft with it, generating electricity. The propeller fits right onto the motor shaft, which sits inside the casing and the motor cap, which you can see coming out right here. Now I couldn't just print all of this willy-nilly, so I made a test print first to see if the motor could fit through. If it could fit through this, then the motor would definitely fit in the casing. Here I spun the motor shaft by hand as a test to make sure that the output of the wires match with the direction of the propeller, which is modeled to spin counterclockwise. You can see the LED lighting up when I do so. Now we get to see my turbine in action. You can see the propeller spinning really fast from the current of the stream moving through it. Now because I was unable to get the LED to light up by hand with the propeller attached, I decided to just tape up the wire hull and test the propeller and waterproofing during this phase. The entire body of the turbine was waterproofed using Flex Seal to cover any cracks or seams that may be opened from either 3D print errors or places where the turbine is being assembled, like between the cap and the main body of the turbine. The propeller was sanded down to be smooth after being printed, and then was covered in Flex Seal to ensure a solid surface for the wire to push against. This mini turbine is small enough to be brought with you while camping or hiking or whatever needs may be while out in the wilderness, and it theoretically could charge your phone or a portable charger. You can see here how I moved some rocks together to make a narrower path for the water to travel through so that the turbine could spin as fast as possible. The strength of the flow comes from the water passing through this little drop next to the rock here, which then goes on to flow through the turbine. Here you can see a broader view of the beautiful stream I used. The water here is quite calm until you get to the point where I put the turbine. The water flows along and gets to this more rapid area where the water flows down and through the rocks. You can also see the water flowing from above here, through the front, and out the back, where it continues on flowing for a while. Here's a closer look at how the LED light strapped to the USB port turns on from the spinning of the propeller. I did this test to make up for not showing the LED in the test where the turbine was actually in the water. Now you might think that a leaf blower would be enough to turn on something like a power bank, but it actually doesn't here. You can see that the LED is turning on, but not the lights on the front of the power bank, indicating that it is charging. The leaf blower was less powerful at first, and was similar to the spin I got from the stream, but even the later, more powerful blow from the leaf blower wasn't enough to show the power bank charging. I'm not certain yet if this is the power bank just not charging at all, or if it's just not strong enough to be picked up on by the sensor. This is something I'll be working on in the future to solve, as this is just the first iteration of my turbine, and I will work to improve upon it and make it more functional in the future. I had tons of fun with this project, and I would definitely recommend iSTEM 3 to any future iSTEM students.